Hey everyone, welcome back to Code and Parallel, where we take complex tech concepts and break them down into bite-sized, easy to understand tutorials. Today we're diving into something every modern developer needs to master: how to build a complete cloud operation using Blazor 8 and clean architecture. In this tutorial, I'm not just going to show you the basic, but we're going to build a scalable, maintainable CRUD application step by step while implementing clean architecture, which is a key design pattern that separates your logic, keeps your code clean, and future-proofs your application. So what are we building? We're going to build a customers application. So as you can see here on the home page, we have a customers page. So what you can do here is add a customer. I can put my name there, Jane Doe, put the email and save. It will bring the customer there. I can add another customer, say Jane Doe. I can add them there. You see, you're able to get the list. I can edit Jane Doe to Jane Doe 2 and save that. I can also delete a customer. So you will see that in just a few clicks, you're able to implement a cloud application using Blazor and clean architecture approach. So grab your coffee, hit that subscribe button if you haven't already, and let's get right into it. So our first order of business is to create a project, set up our solution so that we have adhered to clean architecture. So the first thing you're going to do is open up a Visual Studio 2022, select create new project, and we want to start from scratch. So I will pick a blank solution. I have it here, but you can also search there. So get a blank solution. Next, give it a general name. This is the core banking app, YouTube. Then I'm going to create that. The heart of any clean architecture project, there is what we call the core, and this is made up of the domain and the application layer. They are called the core together. So these are independent of any sort of implementations, database, APIs, whatever. This is just what dictates what your app will do. And you'll see that the domain and the application will just set out the contracts of the things that the application will do. And the other layers will worry about that. So I'll create a folder, add a solution folder, and I'll call this core. You don't have to do this, but I just want to show that this is the core. So just for you to understand. Then I'll add a project, which will be a class library, and I'll call that project domain. So I'll just copy the solution name and put a dot and append domain. So this one, at the bare minimum, it's just going to have entities. So once it's created, I can just delete that. Then I'm going to add a folder, which I'm going to call, I'm going to add a folder. I will call that entities. Okay, entities. And within that, I'll add models that would befit a banking application. So one benefit for you doing this course is you'd also see how we can play around with entity relationships. So one-to-one, one-to-many. We'll try to do one-to-many so as you see. Then we'll leave the rest for entity framework to see how we can do. So I'll add a class. The first one will be called account. Obviously you need to have a bank account. So create a class called account. Once that's created, an account should have an ID that uniquely identifies that. So put prop int ID. An account should have a balance. So prop decimal, call that balance. An account should be tied to a customer. So the customer is yet not created. So customer get and set. Let's create that. Control dot, and you're going to select genotype customer down there. And then also you need to link, if if an account has a customer, then there has to be one thing that links these two tables called a foreign key, because it's a one-to-one, right? So it means I have to create something called a customer ID. The customer ID will be responsible for linking these two, and we'll see how that's best done. An account can have a list of transactions, public list of transaction. Now this transaction is not the one that comes out of the box. Transaction. So transaction, we'll make that nullable because when you create an account, it's not always going to have transactions. So just give the user the option there to have the option not to have those. Okay. So an account of an ID will have balance, customer, and customer ID. Then a customer also. What information could you have in a customer? You might want to have the ID, the name of the customer, the address is called this email, and you might also want to have the phone number, right? Just to know who the customer is. And we'll talk a little bit about validation. So a transaction should have an ID, an amount, a date, a type. Let's not overcomplicate it. I'm going to move amount, date, no need for type. Just trying to keep it simple here. And also an account ID. So there's an idea, a concept of validation, so that when you get to your Blazor app, when you input, if it fails to validate, it should let you know. So I'm going to put what we call data annotations, just to show you how it's done. So you can say this field is required. Without that, don't proceed. This one can also be required. We can fine tune to say this should also be an email address. Again, for the phone number, it is what? It is also required. Okay, right. Required. There you go. Let's push this into their own classes, into their own files, so that we don't violate the single responsibility principle. All right. So your domain is pretty much done at the bare minimum. I'm gonna create the next project, and that will be called the application. And this application will have the use cases of your application. So it will be called banking app.yt. Then I'll call this application. Then I'm gonna create within it. I'm gonna create a folder which we are going to call. Let's call it use cases, but I'll call it interfaces, so that we get to grasp the idea. So I'll add a folder. I'll call this interfaces. Now there are a lot of use cases you can have in your application. For instance, I'll add the first. I would say create an item, and this item will be called an interface. I'll call this an customer repository, like so. And I will make it public, and I'll do it 2 times to also bring the other repositories there. One will be customer, one will be account, and the other will be transaction. So what the application will do is it will just say, I expect the following operations on these entities, or else I expect my application to have the following. So for instance, for the customer, we can have, I can say task, then you could say task, add a sync, and you can say customer. Now there's an error there. It's saying we don't know what customer is, because customer is in domain. So you need to add a reference from application to domain. The application is going to depend on the domain, nothing else, right? The domain is independent. So if you do that, you say, okay, fine, give me the entities. So what are we doing in the application? we are setting out what the business logic of our application would be. So whatever logic you do in your application, it should be here in the application. For instance, as far as the customer is concerned, we want to add a customer to our bank application. You might do the same for add an account or make a transaction, and we'll do this as we go along. But you see that here, all it is saying is I want you to have a functionality to add a customer. It does not implement. So the core of our application, these two, do not worry about what sort of database am I going to use. It's clear on that. That will be the functionality of the infrastructure. All right. So we've done this. Again, let's move this into its own classes so that we do not violate anything. And our core is done. Obviously, we'll be adding as we go. Now, I'm going to add another project, which will be called infrastructure. So let's add a class library, and this will be called core banking app, YT.infrastructure. This is where the plumbing is going to happen. So if we want to add a customer to our application, then we need to say, where are we going to store that information? Are we going to store it in a file? Are we storing it in a database? Are we just passing it to another storage API? These are the decisions that are made in the infrastructure. In our case, we want to use a database called SQL Server, right? The SQL Server database, and the ways and means which we save, we're going to use Entity Framework Core. So these are the concerns that will be done here. It means the logic add async in the core will still be the same, but I can change the way I do it in infrastructure. I can change the way I use the database. I could use Entity Framework Core, or I could use Dapper. The domain, the application, the core couldn't care less as long as you do the functionality. So in the infrastructure, I'm going to delete this. And since we're using Entity Framework, then we need to bring in Entity Framework to allow us to do that. So you right click on the dependencies, then you're going to select manage NuGet packages, and you're going to bring in Entity Framework. And the things that are very important in this infrastructure would be, one, the provider, which is the SQL Server. That would be necessary for us to know which database we're talking to, because it could be a NoSQL database, it could be a MongoDB, it could be a Postgres, which would make us use another provider. You want to bring in tools. Tools is going to help you with creating the actual database and making the migration, as we'll see in this video. So once you've added those, Entity Framework has a concept of the context, which is the window for you to talk to your data. So the infrastructure will depend on the application layer, nothing else. Okay, so I'll add the dependency there. Then I'll create a folder which I'll call context. You can have multiple contexts, so it's better to group them so that you can easily maintain them. So I'll create a folder called context. Then within that context, I'll create a class which I'll call banking DB context. That will be the window to the database, banking DB context. You are not limited to what you can use on the name of the context as long as it makes sense. So each context, for a context to be a context, it needs to use Entity Framework because it has that already. So it will be, there's a class called DB context. So we're going to inherit from that, and this will give us the ability to, you guessed it, use those features. So you bring in a constructor. The constructor takes in a DB context options, which just takes the context. It takes an options, and we're going to pass these options to the base, like so. So pass this to the base options. So now we need to bring in the model. So I'll say prop db set get me an account. I'll call the table account. We can do the same for customer. db set customer. Call the customers. then one more for transactions. Then there's something I just want to show you that you can bring in. As you can see in our entities, customer, we had put in what we call data annotations. The other way to do it is flow and validations. And flow and validations is what I'll use to show you how to also bring in entity relationships. So when the context is being called to create the database, you can override a method which allows you to put your configurations. So for instance, you'll see here, okay, let me remove that so that you're clear on how we did that. If you override, there will be a method called on model creating. This is very important. As you're creating the models, there's something I want you to do. So I just want us to play around with the customer to show that a customer can have many accounts. So what you do is you take the model builder, you say customer has many accounts. Now, if we go to the customer class, you will see that it has a list of accounts. So this list here, it knows that that's many. So a customer has many accounts and one customer. And what links these two, the customer and the account, is the customer ID. That's your foreign key, which you will see here we have put it. So this is also another way through which you can make relationships. So moving on, this is how you do one-to-many. Moving on, we've done a database context, but we need to know where the database is. So I'm going to bring in the Blazor application as the fourth application altogether. And this is where, so the Blazor, the MVC, whatever API comes with the database, I mean with the dependency injection container, which just manages what we have as our dependencies. So I'll add a project, and I'll call this project Blazor Web App, right? So look for Blazor Web App, which is here, and then let's create that. I'll call this UI user interface. So next, we'll use the server variant, and interactivity will be done per component, and we'll see as we go. Then we're going to create that. Blazor comes up with the program.cs, so it means it has the DI container, which will manage our dependencies. So this is where we're going to add all the dependencies in our application. And we'll also tell where the database would be. So the first thing is, I want to know where I will put the database, right? So I'm going to add in the app settings of Blazor, there's a configuration called connection string, which comes out of the box. And we're going to use a local instance, which is in Visual Studio. So Visual Studio has a baked-in SQL Server local DB in there. So I'll say local DB, then you say / MySQL local DB. So it knows that this one is the one that is local DB. Then we have what we call a database. I'll call this core bank YouTube YTDB. Then I'll add what we call a trusted connection so that it knows that as long as I'm logged into my PC, it can give you access to that. I'll set that to true. Right. No need to put these ones here. So we're saying in our local instance of the server, which is within Visual Studio, create a database called core and allow me access to go in and do what I want because I'm logged into my PC. We also need to create the actual database, which we have not yet done. Back to our infrastructure, we do have a context. Our context has been done. Our context has been created. We need to point where the database would be. So the first thing would be I'll go to the Blazor, then I'll add the DB context. But before I do that, remember we said the infrastructure is where you implement these things. Now remember in our application we have things that we have, for instance, we have the iCustomer repository here, right? So we're going to create what we call repositories also in our infrastructure. So I'll create a folder. I'll call the folder repositories, like so. And one of the repository will be I customer repository. So I'll create a class there, and this class will be called customer repository, and this class is going to implement, so let's make it public, and this class is going to implement the I customer repository, and need to say there's an error because we have to implement that functionality. Again, this is the core of our application telling us if you want to implement this, then you need to add a user. For you to talk to the database, we have our database context here, which is the window. But since this is Blazor, I will not use the context right out of the box. I will use what we call a DB context factory, because the components in a Blazor, and you see it as we get there, they might have different life cycle. And if we do the scoped with the DB context, it might not perform well. But if we use the DB context factory, this will allow us to create our DB context on demand, and that will suit well with our Blazor use case. So what I'll do is I'll say private lead only. So private lead only, banking, DB context. Then I'll bring in a constructor, and I'll pass in an I DB context factory, which takes in the name of the context, where the context now is what? The banking DB context. And I'll call that factory, like so. Then I'll say the context which I have there will just be every single time I call this constructor, create for me a DB context. That way, that one makes more sense. So it means I will not implement this in this video, I'll do it in the next, but I just want to show you that we have implemented this. So now in our dependency injection container, we need to tell it that we have a dependency. So I say builder.services.add db. That will not do anything because we're trying to bring in entity framework and we don't have it. So for us to be able to add that, we need to add a NuGet package of entity framework, which is called design. Apologies, not that. So let's go there and select NuGet packages, and let's find the design component, entity framework design, which will now enable us to do that. So there's design, install that. Once that's installed, then we should be able to go back there and say, so now we need to add that DB context. So you say builder.services.add DB context factory. Okay, I wonder why it is not add DB context factory, and it's going to take in the banking DB context. Okay, so one thing I've realized is this one also needs to rely on the application as well as the infrastructure, just for the sake of the DB context. So I will try to bring this in, bring the context. Then remember the context wants to get an option, so we'll give it that option there. So we'll say options is equal to options dot use SQL Server, right? Then we need to give it the place where the location is. So since we have it in our app settings, then we use the configurations, which is built in on the builder. So builder dot configurations dot get connection string. Then we need to give it the name of that. Once we've done that, the name there is default connection, which we're going to put there like so. And once we've done this, we have another dependency, which is we have the I account repository, I customer repository, we have this customer repository. So for that one, we also need to bring in that dependency. So then we'll say also, we also want to get the builder.services.add scoped. So get me the I customer repository as well as the customer repository. Then once we get that, we do this. So just want to run it to see that I have not broken the Blazor application, and it will say a class library cannot be a starter. So go to the Blazor app, right click, make it a starter project, not configure, but rather just right click and say set a starter project, then run it and see if the Blazor is still there. So the Blazor app is okay. All right, fair enough. Let's go and create the database. So we're going to go to tools. You're going to select NuGet Package Manager, then Package Manager Console. And once it loads, you're going to use the keyword add hyphen migration. And we'll say initial DB creation. And it says the target domain doesn't match. So the thing is, we are running in the infrastructure, so you're better off doing that in the infrastructure. These things happen, but it's good to know why that error. So the infrastructure is what has the context. The red there is just to do with the database validation. I mean the decimal validation, so don't worry about that. But we'll see that once we run the migration, it shows you that there's a table customer there. That's the private key, the primary key rather. Then you also see the foreign keys as we had done. So stuff like that. Now for us to create the database, we're going to say update database, which will now go out of its way and create for us a database. You'll see a bunch of SQL commands there showing you that database has been created. Perfect. Now if I go to the SQL Server Object Explorer, which can be found when you click view here, click view, there's that SQL Server Object Explorer there. If I click on it and look at the local DB and go to the app settings, we wanted our DB to be core bank YTDB, and go to databases there, you have your core bank DB there with your subsequent tables. Anyway, thanks a lot for this video. The next video is we're going to work with the front end. Then we're going to see how can we use the front end to serve an actual customer. Thank you and see you in the next video.